Hi, I'm Neil deGrasse Tyson, and today I will tell you 100 mind-blowing facts about the solar system, the planets, the sun, the moons that will change the way you see it forever. Let's dive in. Number one, the moon orbits inside Earth's atmosphere. You might think the moon travels far beyond Earth's atmosphere, but it doesn't. In fact, the outermost layer of our atmosphere, called the exosphere, stretches more than 600,000 kilometers into space. That's farther than the moon's orbit, so technically the moon moves within the very thin edge of Earth's atmosphere. The exosphere is made of scattered hydrogen and helium atoms so sparse that you'd never notice them. But it still counts as part of Earth's atmospheric shell, making our planet's atmosphere much bigger than most people realize. Number two, Mercury has a comet-like tail. Even though Mercury is a planet, it behaves a little like a comet. The intense heat from the sun blasts atoms, especially sodium, from its surface into space, forming a long, glowing tail. This tail always points away from the sun, just like a comet's. Why in this direction? The tail forms and points backwards simply because the sun is constantly blowing outwards, and Mercury is right in the middle of that wind. Number three, Venus spins backward. Venus is often called Earth's twin because it's similar in size and composition. But there's a strange twist, literally. Venus rotates in the opposite direction of most planets. That means if you stood on Venus, you'd see the sun rise in the west and set in the east. Astronomers think Venus flipped its rotation after a giant collision long ago. Number four, Earth used to have a twin moon. Billions of years ago, scientists believe Earth might have had two moons. The smaller one, about the size of Mars's moon Deimos, probably orbited alongside the larger moon before eventually colliding with it. The impact could explain why the moon's far side is rough and mountainous while the near side is smooth. Number five, Mars has blue sunsets. On Earth, sunsets glow orange and red because our atmosphere scatters blue light. On Mars, it's the opposite. The thin, dusty Martian air scatters red light away and lets blue light travel straight. That's why the sun sets in a cool blue hue on Mars. The same dust that turns the sky rusty during the day gives Martian sunsets their ghostly, ocean-colored glow. Number six, Jupiter has the shortest day of all planets. Jupiter is the biggest planet in the solar system, but it also spins the fastest. One full rotation takes less than 10 hours. That means its day is shorter than any other planet's. The rapid spin causes Jupiter's shape to bulge at the equator, making it look slightly squashed. This fast rotation also powers enormous wind belts in the red spot, a storm that's been raging for at least 350 years. Number seven, Io powers part of Jupiter's auroras. Io, one of Jupiter's moons, is the most volcanic world in the solar system. Its volcanoes shoot out sulfur and gas into space, creating a big cloud around it. Jupiter has a very strong magnetic field. As Io moves through it, the charged particles from those volcanoes create electric currents that travel back to Jupiter. When those currents reach Jupiter's poles, they make the gases in the atmosphere glow, forming bright auroras like Earth's northern lights, but much stronger and more colorful. Number eight, Saturn's North Pole has a perfect hexagon. When scientists first saw Saturn's North Pole through Voyager's cameras, they were shocked. Instead of a round storm, they saw a perfect six-sided shape swirling in the clouds. This hexagon is a massive jet stream about 3,000 kilometers wide, larger than Earth itself. The shape forms naturally from the way Saturn's gases move and rotate. A perfect example of order emerging from chaos. Number nine, Uranus rolls around the sun on its side. Uranus is unlike any other planet. It spins almost completely on its side with a tilt of about 98 degrees. Instead of rotating upright like Earth, it rolls around the sun like a ball lying on its side. Scientists believe a huge collision with another planet-sized object billions of years ago caused this strange tilt. Because of that, its poles point almost directly toward and away from the sun during its long orbit. Each pole experiences about 42 years of nonstop sunlight, followed by 42 years of total darkness. Number 10. Neptune's winds are the fastest in the solar system. Neptune's atmosphere has winds that can reach 2,100 kilometers per hour, faster than the speed of sound on Earth. But why are they so strong? Neptune gets very little sunlight, less than 1/900th of what Earth receives, so scientists think the planet produces its own internal heat deep inside. This hidden energy rises and drives powerful convection currents, stirring the atmosphere like boiling water. Combined with Neptune's fast rotation, this energy creates huge pressure differences that speed up the winds to incredible levels. Number 11. Pluto has ice made of nitrogen. Pluto might be tiny, but it has a fascinating surface. Most of its plains are covered in nitrogen ice, not water ice like we find on Earth. Nitrogen freezes at extremely low temperatures around minus 346 degrees Fahrenheit. On Pluto, that's just another day. When sunlight hits this frozen nitrogen, it can slowly vaporize and form a thin atmosphere. As Pluto moves along its long orbit, the atmosphere collapses and refreezes onto the surface. Number 12, Jupiter is approximately 318 times the mass of Earth. Furthermore, it is more than 2.5 times more massive than all the other planets combined. That means that if you were to combine Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune into a single mass, Jupiter would still weigh more than that combined mass. Number 13, Sedna has one of the longest orbits known. Sedna is a dwarf planet way out beyond Pluto, and it has one of the longest orbits ever discovered. Its path around the Sun is extremely stretched out, like a very elongated ellipse. Because of that, it takes about 11400 Earth years to complete one full orbit. When Sedna is near its closest point, it's about 76 astronomical units from the Sun. At its farthest, it drifts out to around 937 AU. That's over 900 times farther from the Sun than Earth is, because Sedna spends so much time extremely far away. Number 14, Jupiter has a moon with an ocean larger than Earth's. Beneath the icy surface of Europa, one of Jupiter's largest moons, lies an ocean estimated to hold twice as much water as all of Earth's oceans combined. Scientists think the heat generated by Jupiter's gravity, called tidal heating, keeps this ocean liquid beneath the ice. That makes Europa one of the most promising places to look for alien life. Number 15, Saturn could float in water. If you could find a bathtub big enough, an impossible one of course, Saturn would float. That's because Saturn's average density, how much mass fits into a certain volume, is less than that of water. Its lightness means Saturn is more like a cosmic balloon than a solid world. Number 16, Neptune was discovered through math before being seen. Neptune's discovery is a perfect example of how mathematics can uncover what eyes can't yet see. In the 1800s, astronomers noticed that Uranus wasn't following its expected orbit. It moved slightly off track, as if something invisible was pulling on it. This mystery led two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, to use Newton's laws of gravity to predict where that hidden planet must be. Their calculations showed exactly where to look in the night sky, when astronomers pointed a telescope to that spot in 1846. Neptune was found almost immediately. Amazing, right? Number 17, the Sun's atmosphere is hotter than its surface. It sounds impossible, but it's true. The Sun's visible surface, called the photosphere, has a temperature of about 10000 Fahrenheit degrees, yet the layer above it, known as the corona, reaches millions of degrees. Scientists still don't fully understand why. This strange phenomenon means the farther you go from the Sun's surface, the hotter it gets, up to a point where it's millions of degrees hotter than the part we can see. Number 18, the asteroid belt isn't as crowded as movies show. In science fiction, spaceships dodge rocks like they're in a cosmic obstacle course. Reality is far emptier. The asteroid belt, located between Mars and Jupiter, contains millions of objects, but they're spread out over such a huge area that the average distance between asteroids is about 1,000,000 kilometers. You could fly straight through it and never hit a thing. Number 19, one of Saturn's moons looks like the Death Star. Saturn's moon Mimas is small, only about 400 kilometers wide, but instantly recognizable to Star Wars fans. The resemblance comes from a gigantic impact crater named Herschel, about 1/3 the size of the whole moon. Scientists believe a massive asteroid hit Mimas billions of years ago with enough force to almost destroy it. The energy from the collision cracked its surface and left a huge central peak that resembles the super laser crater from Star Wars. Mimas survived only because it's made mostly of ice, which absorbed some of the shock instead of breaking apart completely. Number 20, Eris is more massive than Pluto. Astronomers discovered Eris in 2005 and noticed it has a small moon called Dysnomia. By tracking Dysnomia's orbit around Eris, how far it is, and how long one lap takes, they used Kepler's laws to calculate Eris's mass precisely. The result? Eris is about 27% heavier than Pluto, even though their sizes are similar. That extra mass and higher density showed Pluto wasn't unique among distant icy worlds, helping trigger the 2006 move to define dwarf planet and reclassify Pluto. Number 21, there are more moons than planets in our solar system. While there are only 8 planets, there are over 290 confirmed moons orbiting them. and counting. Jupiter and Saturn alone hold the majority, each with more than 100 moons. Some are larger than Mercury. Number 22, Venus is the hottest planet, not Mercury. You might think Mercury is the hottest planet since it's closest to the sun, but that title actually belongs to Venus. Venus's thick carbon dioxide atmosphere traps heat in a process called the greenhouse effect, creating average surface temperatures around 475 Celsius degrees. That's hot enough to melt lead. Mercury may get intense sunlight, but without much of an atmosphere to hold heat, it cools down quickly. Venus, meanwhile, stays an inferno day and night. Number 23, Jupiter's Great Red Spot is shrinking. Jupiter's Great Red Spot is a massive storm that has been swirling for at least 350 years, so huge it could once fit 3 Earths inside. But over the last century, scientists have noticed it's getting smaller and rounder each decade. The exact reason isn't fully known, but there are strong clues. Jupiter's atmosphere is full of smaller storms and turbulent jet streams that constantly interact with the red spot, stealing energy from it or breaking off pieces around its edges. Over time, this weakens the storm and makes it spin faster but cover less area. Number 24, there are storms on Saturn that last for years. Saturn's calm look hides a world of extreme weather. About every 30 Earth years, an enormous storm called the Great White Spot erupts in its atmosphere. But why do these storms last so long? Scientists think it's because of Saturn's deep, cold atmosphere made mostly of hydrogen and helium. Heat builds up slowly deep inside the planet until it suddenly bursts upward, releasing massive energy. Since Saturn spins fast and has no solid surface to break the flow, the storm's clouds can spread around the entire planet and keep circling for months or even years. Number 25, a day on Venus is longer than its year. Venus rotates so slowly that one full spin on its axis takes 243 Earth days. Meanwhile, it orbits the Sun in just 225 days. That means a day on Venus, one full rotation, is longer than its entire year. So if you were standing there, you'd see the Sun rise only once every Venusian year. Number 26. Some asteroids have moons. You might picture asteroids as lonely rocks floating through space, but some actually have tiny moons orbiting them. For example, the asteroid Ida has a small moon named Dactyl, discovered by the Galileo spacecraft in 1993. Scientists believe about 15% of large asteroids could have small companions. Number 27, Uranus smells terrible. It may sound funny, but it's true. If you could smell Uranus, it would stink like rotten eggs. That's because its atmosphere contains hydrogen sulfide, a gas that has that unmistakable odor. On Earth, we only encounter it in small amounts from volcanic gases or decaying matter. On Uranus, it's part of the air itself. Of course, you couldn't actually smell it in person because you'd freeze or suffocate long before, but it's one of the more unpleasant cosmic facts out there. Number 28, there's a diamond rain on Neptune and Uranus. Both planets are rich in methane, a gas made of carbon and hydrogen, under the extreme pressure and heat deep below their thick atmospheres. Methane molecules break apart. The carbon atoms then squeeze together into diamond crystals. These tiny diamonds fall through the atmosphere like rain, getting larger as they descend. As they sink even deeper, the pressure becomes so intense that they might melt, forming layers or even oceans of liquid diamond. This happens because these planets have temperatures thousands of degrees high and pressures millions of times stronger than Earth's atmosphere. Perfect conditions for turning carbon into gems. Number 29, the solar system smells like hot metal and raspberries. Astronomers studying interstellar clouds and comet gases found that many of the same molecules that make up smells on Earth exist in space. For example, ethyl formate, the molecule that gives raspberries their sweet scent, has been detected in space dust. On the other hand, comets and some planets' atmospheres give off metallic or sulfuric smells like burning metal or gunpowder. Number 30. The sun's magnetic field flips every 11 years. Every 11 years, the sun's north and south magnetic poles switch places. This happens because the sun is made of hot, moving gas called plasma. As the plasma swirls and flows inside, it twists the sun's magnetic field more and more like tangled strings. After a while, the magnetic field becomes so twisted that it snaps into a new shape, flipping completely. During this time, the sun becomes very active with more sunspots, flares, and big explosions of energy. Once the flip is done, the sun calms down again and starts a new 11-year cycle. Number 31, there's a planet made mostly of diamond. Far beyond our solar system lies a planet called 55 Cancri E, and it's believed to be made largely of diamond. Scientists think it formed around a carbon-rich star, allowing carbon atoms to crystallize under pressure deep inside. The planet is about twice the size of Earth and orbits so close to its star that a year there lasts just 18 hours. If it truly has a diamond interior, its total worth would be beyond imagination, though it's far too hot to ever visit. Number 32, the Kuiper Belt is the solar system's final frontier. Beyond Neptune lies the Kuiper Belt, a vast region filled with icy bodies, comets, and dwarf planets like Pluto, Haumea, and Makemake. It's similar to the asteroid belt, but far larger, stretching billions of kilometers across. The Kuiper Belt is the frozen edge of our solar system, where sunlight is weak and time seems to stand still. Number 33, Pluto has a heart-shaped glacier. When NASA's New Horizons spacecraft flew past Pluto in 2015, it revealed a stunning feature on the surface: a giant heart-shaped region. This bright area, officially named Tombaugh Regio after Pluto's discoverer, is a massive glacier made mostly of nitrogen ice. The heart covers an area roughly the size of Texas and Oklahoma combined. Number 34, Jupiter emits more heat than it receives from the sun. Jupiter is so far from the sun that it gets very little sunlight, yet it gives off more heat than it receives, and here's why. Deep inside Jupiter, the planet is slowly shrinking under its own gravity, a process called Kelvin-Helmholtz contraction. As Jupiter's massive layers of gas compress over time, that pressure turns gravitational energy into heat, which then escapes from the planet's interior. This slow release of energy acts like a natural heater, warming its atmosphere from the inside. That's why Jupiter's clouds, storms, and giant systems like the Great Red Spot stay so active. Number 35, one of Neptune's moons orbits backward. Triton, Neptune's largest moon, moves in the opposite direction of Neptune's rotation, something very unusual. This backward or retrograde orbit is the main clue that Triton didn't form with Neptune. Scientists believe Triton was once a dwarf planet like Pluto, orbiting the sun on its own. Long ago, it passed close enough to Neptune for the planet's strong gravity to capture it. That capture reversed Triton's path, forcing it to orbit backward. This sudden change likely created huge tides and friction inside Triton, heating it slightly and causing the nitrogen geysers seen today. Number 36, there's a mountain on an asteroid taller than Everest. On the asteroid Vesta, there's a colossal mountain called Rhea Silvia, rising about 22 kilometers high, almost 3 times taller than Mount Everest. But why is it there? Scientists believe Rhea Silvia formed after a massive asteroid impact billions of years ago. The force of the collision was so powerful that it blasted open a gigantic crater, pushing rock from deep inside Vesta upward to form the huge central peak. The impact also sent chunks of Vesta flying into space. Some eventually landed on Earth as meteorites. Number 37, Saturn's rings are disappearing. Saturn's beautiful rings aren't permanent. NASA's Cassini spacecraft discovered that they're slowly falling onto the planet as a type of ring rain. The particles that make up the rings, mostly ice and dust, are being pulled in by Saturn's gravity and dissolved by its atmosphere. At the current rate, the rings could disappear in about 100 million years. Number 38, Mercury has ice at its poles. It sounds impossible, but Mercury, the planet closest to the sun, actually has ice at its poles. The reason lies in the planet's lack of tilt and its extreme surface conditions. Mercury's axis is almost perfectly upright, so sunlight never reaches the deep floors of some polar craters. These areas stay in permanent shadow, hidden from the sun's heat for billions of years. Without sunlight, temperatures there can plunge below minus 290 Fahrenheit degrees, cold enough for water ice to remain solid. The ice likely came from ancient comets or asteroids that hit Mercury and left behind water, which then froze in these dark, sheltered craters. Number 39. The sun makes a sound, but we can't hear it. The sun constantly vibrates and produces waves that ripple through its surface. These movements create sound waves. Though they don't travel through space because space is a vacuum, there's no air to carry sound. However, scientists have translated these vibrations into audible tones using data from solar observatories. The result is an eerie humming symphony, a kind of heartbeat of our star that we can finally listen to through science. Number 40, Jupiter's magnetic field is 20,000 times stronger than Earth's. Jupiter's magnetic field is so powerful because of what's happening deep inside the planet. Beneath its thick clouds, the immense pressure turns hydrogen gas into a strange form called metallic hydrogen, which behaves like a liquid metal that conducts electricity. As Jupiter spins rapidly once every 10 hours, this metallic hydrogen moves and generates a huge electric current, creating a magnetic field about 2,000 times stronger than Earth's. This field creates intense radiation belts, powerful enough to damage spacecraft electronics in seconds. Number 41, Mars once had rivers and lakes. Long ago, Mars looked very different, warmer, wetter, and covered in rivers, lakes, and maybe even oceans. But why did it all disappear? Scientists believe Mars once had a thick atmosphere that trapped heat and kept water stable on its surface. Over time, Mars's magnetic field weakened and vanished, leaving the planet unprotected from the solar wind, a stream of charged particles from the sun. This wind slowly stripped away Mars's atmosphere, causing the planet to lose most of its air and warmth. Without enough pressure or heat, the water evaporated or froze, leaving behind only dry channels and icy polar caps. Number 42, some comets spit ice and gas in multiple directions. Some comets spit in many directions because they're lumpy, porous snowballs of ice and dust with lots of cracks and vents. As a comet gets closer to the sun, patches on its surface warm up and the ice there turns directly into gas. That gas bursts out through different vents like little geysers, carrying dust and ice grains with it. Since the comet is irregular and spinning, sometimes even wobbling, different spots face the sun at different times. So new jets switch on while others shut off. The result is multiple jets pointing different ways. Number 43, the sun will one day swallow Mercury and Venus. In about 5 billion years, the sun will reach the end of its life as a normal star. Right now it shines by fusing hydrogen into helium in its core, but when that hydrogen runs out, gravity will squeeze the core tighter. This compression heats it up, causing the outer layers of the sun to expand enormously. The sun will become a red giant, hundreds of times larger than it is today. As it swells, its outer layers will reach and engulf Mercury and Venus, completely vaporizing them. Earth might barely survive, or be burned and stripped of its atmosphere. Eventually, the sun will shed its outer gases into space, leaving behind a small, hot core called a white dwarf. Number 44, Jupiter acts as Earth's shield. Without Jupiter, Earth might have faced far more catastrophic asteroid impacts. The giant planet's massive gravity acts like a cosmic vacuum cleaner, pulling in or deflecting comets and asteroids that might otherwise head toward us. Jupiter is not just the largest planet, it's also one of Earth's best friends in space. Number 45, Venus has mountains taller than Everest. On Venus, there's a mountain called Maxwell Montes, rising about 11 kilometers high. Taller than Mount Everest, the mountain's slopes are covered with metal frost, a shiny coating of metallic minerals that condensed from the planet's hot atmosphere. The crushing pressure and searing heat make climbing it impossible. But if you could stand there, you'd see a glowing, cloud-filled sky and feel the weight of 90 Earth atmospheres pressing down on you. Number 46, a day on Mercury is twice as long as its year. The planet rotates very slowly, taking about 59 Earth days to complete one full turn, but it orbits the sun quickly in only 88 Earth days. Because of the strong pull of the sun's gravity, Mercury got locked into a special rhythm called a 3. 2-spin orbit resonance. It spins 3 times for every 2 trips around the sun. This means that from one sunrise to the next, a full solar day on Mercury lasts about 176 Earth days, which is twice as long as its year. So, even though Mercury races around the sun faster than any planet, its slow spin makes its days last forever under the blazing light. Number 47, some comets have 2 tails. Why? As sunlight heats the comet's icy surface, it releases gas and dust into space. The tiny dust particles are pushed away by the pressure of sunlight, forming a curved yellowish tail that follows the comet's orbit. At the same time, the solar wind, a stream of charged particles from the sun, strips away the comet's ionized gas, creating a second bluish tail that always points directly away from the sun. So one tail is shaped by light and the other by solar wind. Number 48, there's a region where the sun's gravity stops ruling. Far, far beyond Pluto lies a boundary called the heliopause, the place where the sun's influence finally ends. Beyond it lies interstellar space, the region that exists between the stars of a galaxy and is often defined as the point where the solar wind from our sun ceases to have a dominant effect. NASA's Voyager 1 and 2 spacecraft are the only human-made objects to have crossed this boundary. Number 49, Earth's magnetic field is constantly moving. At the planet's core, molten iron and nickel swirl and flow like a giant electric dynamo. These moving metals create electric currents, which in turn generate Earth's magnetic field. But since the liquid core is always shifting, the magnetic field changes too, causing the magnetic poles to slowly drift across the planet, moving about 40 kilometers per year. Over long periods, this motion can even make the poles flip completely. in events called geomagnetic reversals. The last one happened around 780000 years ago. Number 50, there's a wall of hydrogen at the edge of the solar system. As the solar wind pushes against interstellar gas, it creates a buildup of hydrogen called the hydrogen wall. This invisible barrier marks the boundary between our solar system and interstellar space. NASA's New Horizons spacecraft detected it in 2018 using special ultraviolet instruments. It's not a solid wall, of course, it's a dense region of gas that glows faintly where the sun's influence fades into the galaxy beyond. Number 51, Jupiter has a moon that's older than the planet itself. Jupiter's largest moon, Ganymede, may contain material that formed before Jupiter even existed, when the solar system was still a cloud of gas and dust. Small solid pieces called planetesimals began forming first. Some of these ancient chunks of rock and ice were drifting in space long before Jupiter grew massive enough to capture them. Later, as Jupiter formed, its strong gravity pulled in these leftover building blocks and they merged to create Ganymede. So even though the moon itself formed after Jupiter, the moon's raw materials are much older. Number 52. The solar system is moving around the galaxy. Even though it feels like everything in the sky is fixed, our entire solar system is racing through space at about 828000 kilometers per hour. We're orbiting the center of the Milky Way galaxy, completing one full revolution roughly every 230 million years. That means the last time our solar system was in the same galactic spot, dinosaurs were just beginning to appear on Earth. Number 53, there are planets that have rings besides Saturn. Saturn's rings are the most famous, but it's not the only planet with them. Jupiter, Uranus, and Neptune also have ring systems, though much fainter and thinner. Jupiter's are mostly made of tiny dust particles. Uranus's rings are dark and narrow, and Neptune's are broken and clumpy. Number 54, Mars has seasons just like Earth. Mars has spring, summer, fall, and winter for the same reason Earth does. Its axis is tilted. The planet leans about 25 degrees, almost the same as Earth's 23.5 degrees. So as Mars orbits the Sun, different parts of the planet tilt toward or away from sunlight. That tilt changes how much sunlight each hemisphere receives, creating the cycle of seasons. But because Mars takes 687 Earth days to orbit the Sun, each season lasts nearly twice as long as ours. The thin Martian atmosphere can't hold heat, so temperatures swing wildly, from about 20 Celsius degrees on warm summer days to minus 125 Celsius degrees in the depths of winter. Number 55, the largest impact crater in the solar system is on Mars. The Hellas Planitia Basin on Mars stretches about 2,300 kilometers across and nearly 9 kilometers deep. It was created billions of years ago by a massive asteroid impact that reshaped the southern hemisphere of the planet. The crater is so large that it affects Mars's weather, causing air to flow in and out of it like a giant bowl. Number 56, the Sun is about halfway through its life. Our Sun is around 4.6 billion years old, and scientists estimate it has about 5 billion years left before it burns through all its hydrogen fuel. Right now, it's in the main sequence phase of its life, steadily converting hydrogen into helium through nuclear fusion. When that fuel runs low, the Sun will swell into a red giant before shrinking into a white dwarf. Number 57, some asteroids are hollow. Not all asteroids are solid chunks of rock. Some, known as rubble pile asteroids, are loosely held together collections of boulders, dust, and empty space. Their weak gravity is just strong enough to keep them clumped together. When spacecraft have visited these bodies, like Bennu or Ryugu, they've found surprisingly low densities, confirming their porous structure. Number 58, all the planets barely could fit between Earth and the Moon. Honestly, this claim works because we're talking about the gap between Earth and the Moon, about 3,84400 kilometers on average, and we don't include Earth itself. If you line up the other 7 planets, their diameters add up to roughly 3,80000 kilometers, which is just a bit less than that gap. That's why people say they barely fit. Number 59, there's a place on Mars where it snows, but not like on Earth. Yes, it snows on Mars, but not with fluffy flakes of water ice. Instead, it snows dry ice made of frozen carbon dioxide. During the winter at Mars's poles, temperatures drop so low that carbon dioxide from the atmosphere condenses into icy crystals that fall to the surface. The snow is so fine it looks more like fog. When spring comes, the dry ice sublimates directly from solid to gas, creating weird shapes and even small eruptions in the polar landscape. Number 60, a young rogue planet feeding itself in real time. This means a baby planet that doesn't orbit any star is still growing by pulling in nearby gas and dust. Gravity gathers this material into a small disk around the planet, and the stuff spirals down onto it. heating up and glowing so telescopes can see the feeding. In 2025, astronomers watched one such object, CHA 1107, 7,626, about 5 to 10 Jupiter masses and 620 light years away, gulp material at a record rate, roughly 6 billion tons per second, much like a mini-star forming. That's why we say it's feeding itself right now. Number 61, the first interstellar object, Oumuamua. In 2017, Oumuamua entered our solar system from interstellar space. Oumuamua is weird because it came from outside our solar system on a hyperbolic path and isn't bound to the sun. Yet as it flew away, it showed a small extra push that gravity alone can't explain. Even stranger, telescopes saw no comet-like tail or dust cloud, the usual sign of outgassing that would cause such a push. One simple idea is that it released invisible gas, like hydrogen made inside ice, that acted like a tiny rocket but didn't leave a visible tail. Others have suggested sunlight pressure nudged it along. There's still no single agreed answer. Number 62, the moon is sunburned by solar radiation. Why? Because the solar wind, tiny charged particles from the sun, gradually darkens exposed soil. In a few special spots, the crust has local magnetic fields that act like mini shields, deflecting the solar wind so the ground there stays brighter while nearby unshielded areas get darker. Those bright and dark patterns are the moon's swirls, like at Reiner Gamma, and match what models predict when solar wind is blocked or redirected by these small magnetic bubbles. Number 63, infrared emission is key to knowing composition. Infrared light is basically a heat glow, and every object in the solar system gives off this glow. Different materials, ice, rock, metal, methane, etc., glow in slightly different ways, leaving fingerprints in the infrared that scientists can read with special cameras and spectrometers. By measuring how bright the glow is at different infrared colors, we can estimate an object's temperature. Hot things glow more, cold things less, and spot absorption features that reveal what it's made of. Number 64, solar winds damage to spacecraft surfaces. The solar wind is a steady stream of tiny, fast particles from the sun. When these particles strike a spacecraft, they can knock atoms off its surface, like ultrafine sandblasting, called sputtering. Some particles also embed in the material, forming microscopic bubbles that can swell and blister paints and coatings. Over months to years, this erodes metals, roughens mirrors, fades thermal blankets, and reduces solar panel efficiency. The solar wind can also electrically charge surfaces, leading to small discharges that may damage electronics. To fight this, engineers use radiation-hard materials, add protective coatings, and test everything to ensure a spacecraft can survive years of this relentless particle weather. Number 65, solar wind comes in fast and slow streams with different compositions. The solar wind comes in two flavors because it starts in different parts of the sun. From coronal holes where magnetic field lines are open like straight pipes, hot gas escapes easily, so the wind is fast, steady, and thin. From regions with closed, tangled magnetic loops near the sun's equator, gas gets trapped and mixed, then leaks out in bursts, so the wind is slower, denser, and more changeable. Number 66, Comet 3 I/Atlas is an interstellar visitor traveling at 130000 miles per hour. Coming from deep interstellar space, it already had a big head start speed. Then as it falls toward the sun's gravity accelerates it even more, pushing its pace to roughly 130000 miles per hour. Inbound interstellar objects travel on hyperbolic paths, meaning they aren't bound to the sun. As they dive inward, the sun's gravity converts gravitational potential energy into kinetic energy, so they accelerate on approach and then shoot back out to interstellar space. Number 67, the interstellar Comet 3 I/Atlas is losing water very fast. Even far from the sun. Why? Because its surface likely has very easy to evaporate ices and lots of fresh, porous, cracked material. Even in low sunlight, supervolatiles like carbon monoxide or carbon dioxide can start venting. Their escaping gas can drag water molecules with it, boosting the apparent water loss. A dark, dust-coated surface can also soak up extra heat, warming pockets of ice below. Add the comet's huge surface area, from pores and fractures and weak gravity, so gas escapes freely and you get high outgassing rates, on the order of 40 kilograms of water per second, much earlier than we'd expect for a typical solar system comet. Number 68, planets farther from the sun get much less solar energy. Planets farther from the sun get much less energy because sunlight spreads out as it travels. Imagine a flashlight. Close up the spot is bright, But farther away, the same light covers a bigger area, so each bit of surface gets less light. In space, this follows the inverse square rule. If you go 2 times farther, the light is 1/4 as strong. 3 times farther, 1/9 as strong. So at 10 AU, 10 times Earth's distance, the sunlight is 1/100th of Earth's intensity. That's why outer planets are so cold and dim. They simply receive far less solar power per square meter. Number 69, light takes 4 hours to reach Neptune from the sun. Light takes about 4 hours to reach Neptune because it's incredibly far from the sun, around 30 times farther than Earth, 30 AU. Even though light is the fastest thing in the universe, about 300,000 kilometers per second, distance still costs time. 1 AU, the sun-Earth distance, is about 8 minutes of light travel time. Multiply that by 30 and you get roughly 250 minutes, a little over 4 hours. So when sunlight finally reaches Neptune, it's already 4 hours old. A simple way to feel just how deep into the solar system Neptune sits. Number 70, Charon has frozen carbon dioxide and hydrogen peroxide on its surface. Charon is very cold and has no air, so gases that are vapor on Earth freeze into ice there. Sunlight and space radiation hit the surface ice and break water into pieces. Some pieces join back together as hydrogen peroxide, which stays frozen in the deep cold. The same radiation also changes carbon-based ices like methane into carbon dioxide. Because Charon has no weather, no wind, rain, or air, nothing cleans these chemicals away. So they build up in bright cold spots. Number 71, we've literally touched the sun. Parker Solar Probe is a tiny robot ship that flies closer to the sun than any other. It wears a super tough heat shield so it doesn't melt. Near the sun, it tastes the sun's wind by counting particles and feeling magnetic forces instead of guessing from far away. It found the wind sometimes twists in zigzag switchbacks, like a flapping ribbon. By comparing what it feels near the sun with what we feel at Earth, Parker helps us learn how the sun's outer air, the corona, gets so hot and how the solar wind speeds up. Number 72, Neptune's fastest storms were first seen around its Great Dark Spot. Neptune sometimes grows a huge dark storm called the Great Dark Spot, like a giant hurricane on a very cold world. Along its edges, winds roar at about 2,100 kilometers per hour, faster than a jet, faster than sound on Earth. These super winds happen because Neptune spins very fast, has very cold, thin air that creates big pressure differences, and has internal heat pushing energy up from below. With little surface to slow the air down, the winds can keep speeding around the storm, making Neptune home to some of the strongest winds in the solar system. Number 73, Earth has Trojan asteroids too. Yes, Trojan asteroids are tiny space rocks that share Earth's path around the sun. They sit in safe parking spots 60 grades ahead of Earth or 60 grades behind, where the pull of the sun and Earth balances out. Because they stay at those 60 grades angles, they don't crash into us and just tag along. The first one we confirmed is 2010 TK7, found by the WISE Space Telescope. Number 74, Pluto has blue skies and red snow. Pluto may be tiny and far from the sun, but it's full of surprises, blue skies, and red snow among them. The blue color in its sky happens because sunlight hits tiny particles in Pluto's thin atmosphere, made mostly of nitrogen and methane gas. These particles scatter sunlight, especially the blue wavelengths, just like Earth's atmosphere does, creating a soft blue haze. Meanwhile, on Pluto's frozen surface, methane ice is constantly bombarded by sunlight and cosmic rays, which break its molecules apart. The fragments recombine into complex organic compounds called tholins, which have a reddish-brown color. When these tholins mix with the surface frost, they turn parts of Pluto's snow and ice red. Number 75, some moons are volcanic hellscapes. Take Io, one of Jupiter's moons. It's the most volcanically active place in our solar system. It has hundreds of volcanoes that blast out molten rock, sulfur, and sulfur dioxide. These eruptions can shoot material as high as 500 kilometers above Io's surface. But what makes Io so crazy hot and active? It's not leftover heat or radioactive decay, it's from tidal heating. As Io orbits Jupiter, the strong gravity from Jupiter and the gravitational pull from other moons like Europa and Ganymede stretches and squeezes Io. That constant flexing creates friction inside Io, heating its interior and melting rock. Number 76, there's a volcano on Mars 3 times taller than Everest. Olympus Mons on Mars is the tallest volcano and the largest mountain in the solar system. It rises 26 kilometers high, nearly 3 times the height of Mount Everest. Its base is so wide it could cover the entire state of Arizona. Because Mars's gravity is weaker and its crust doesn't move like Earth's, the volcano was able to build up for millions of years, creating a world-sized giant. Number 77. The sun emits a constant stream of particles called the solar wind. The solar wind exists because the sun's outer atmosphere, called the corona, is so incredibly hot, over 1,000,000 degrees Celsius, that it gives particles enough energy to escape the sun's gravity. These particles, mostly electrons and protons, flow outward in every direction at hundreds of kilometers per second, forming a vast bubble around the solar system known as the heliosphere. Number 78. Saturn moon Hyperion is a sponge moon. Hyperion is called a sponge moon because it's unusually fluffy and full of empty space. Instead of being solid rock, it's mostly icy material with lots of gaps inside. About 40% of its volume is literally void. That makes its gravity very weak, so debris from impacts doesn't settle and smooth the surface. When meteoroids hit, they tend to compress the surface rather than melt it, carving deep, sharp-edged craters that stay open like holes. Number 79. The solar system is part of the Milky Way. Our solar system lives within the Milky Way, a spiral galaxy where the sun orbits the galactic center. In fact, we're in the Orion Arm. The Milky Way contains hundreds of billions of stars. Fun fact. That's far more than the current human population of approximately 8.2 billion people. There are dozens of times more stars in our galaxy than people on Earth. Number 80. The solar system smells different on every planet. If you could somehow smell other worlds ignoring the lack of air, each would have its own unique scent. Venus's atmosphere would smell like rotten eggs. Thanks to sulfuric acid clouds, Uranus and Neptune would reek of ammonia, similar to cleaning fluid. Mars, full of iron dust, might have a metallic or burnt odor, and Saturn's moon Titan, rich in hydrocarbons, could smell faintly like gasoline. Number 81, Arrokoth, a snowman in space. Arrokoth is a tiny world far past Pluto that looks like a snowman, two round pieces stuck together. A NASA spacecraft called New Horizons flew by it on January 1st, 2019, and took close-up pictures. Those pictures show the two parts gently joined at the neck, meaning they came together slowly long ago instead of crashing hard. Because Arrokoth lives in the cold, quiet outer solar system, it has stayed almost the same for billions of years. Number 82, Venus's surface pressure is 90 times Earth's. Standing on Venus would feel like being 1 kilometer underwater on Earth. The crushing atmospheric pressure caused by its dense carbon dioxide atmosphere is about 90 times stronger than what we experience at sea level. That's why spacecraft sent to Venus, like the Soviet Venera landers, survived only a few minutes before being crushed and melted by the extreme heat and pressure. Number 83, Uranus has dark, narrow rings and two outer ones. Uranus's ring system comes in two sets, an inner family of 9, which are narrow and dark gray, and two outer rings farther out. Unusually, those outer rings differ in color. One appears reddish because of dust-rich, while the outermost is blue. The rings are intrinsically faint and slender, with many only a few kilometers wide, a fact first nailed down by stellar occultation studies. Number 84, Mars has the largest canyon in the solar system. Valles Marineris stretches more than 4,000 kilometers across Mars, about 10 times longer than the Grand Canyon, and plunges up to 7 kilometers deep. If it were on Earth, it would stretch from California to New York. Scientists think it formed as the Martian crust split apart while volcanoes nearby lifted the surface. Today, it's a scar so vast it would dwarf any natural feature on Earth. Number 85. Some moons have atmospheres. Even though most moons are small and cold, some can still hold onto gases, and that's why they have atmospheres. A moon's ability to keep gas depends on two things: gravity and temperature. If a moon is massive enough, its gravity can stop gas molecules from escaping into space. And if it's cold enough, the gases move more slowly, making them easier to trap. Saturn's moon Titan, for example, is large and very cold, so it holds a thick atmosphere rich in nitrogen, even denser than Earth's. In contrast, smaller moons like Triton and Neptune and Io and Jupiter are constantly losing gas. But volcanic activity or surface reactions keep replenishing their thin atmospheres of nitrogen or sulfur compounds. Number 86, Ceres bright spots are salt from brines. Those dazzling white patches in Ocketer Crater aren't ice, they're salt flats, mainly sodium carbonate with some chlorides. How did they form? A big impact cracked and warmed Ceres crust, letting salty water rise from a deep reservoir. When the brine reached the surface, the water boiled off, sublimated, leaving bright salt deposits behind. Some spots contain hydrohalite, which breaks down quickly in space, so its presence means recent brine activity. The salts are so reflective that they create Ceres's famous bright spots, Cerealia and Venalia faculae. Number 87, Quaoar's ring breaks the rule. The dwarf planet Quaoar's ring breaks the rule because rings are expected to survive inside a body's Roche limit, a minimum distance that an object can support orbiting a massive body. In 2020, astronomers spotted a dense ring around the Kuiper Belt dwarf planet Quaoar at about 4 Quaoar Radii, well outside that limit. Using precise starlight blink measurements, a stellar occultation. Follow-up work shows 2 narrow rings circling Quaoar, confirming this odd, long-lived setup. Number 88, Mercury shrinks as it cools. Mercury is slowly getting smaller because of what's happening deep inside it. The planet has a huge iron core that takes up most of its volume. When Mercury first formed, this core was extremely hot. Over billions of years, it has been cooling down, and as metals cool, they contract, just like metal shrinks when it gets cold on Earth. This slow contraction causes Mercury's outer rocky crust to wrinkle and crack, creating giant cliffs called lobate scarps that can stretch for hundreds of kilometers and rise over a kilometer high. Because Mercury's surface is solid, it can't expand again, so the wrinkles stay. Number 89, the inner planets Mercury and Venus mostly lack moons. This is because the sun's gravity is too strong nearby, and the planet's gravitational reach is small. For Mercury, the sun's pull and tidal forces would quickly destabilize any tiny captured rock, either dragging it down or flinging it away. Venus likely faced similar problems, and a giant ancient impact may have scrambled its spin. It now rotates very slowly and backward, making long-term satellite orbits harder to keep. Number 90, the solar system is surrounded by a giant cloud of comets. The Oort cloud exists because of how the solar system formed and evolved billions of years ago when the planets were still taking shape. Countless icy objects orbited the young sun. Many of them were flung outward by the powerful gravity of Jupiter and the other giant planets. Instead of escaping into interstellar space, these icy leftovers spread out into a vast spherical shell that now surrounds the solar system. This region, the Oort cloud, may contain trillions of comets, stretching halfway to the nearest stars. Occasionally, a passing star or the gravity of the Milky Way nudges some of these frozen bodies, sending them toward the sun as long-period comets. Number 91, Mercury has a dust ring. Mercury seems to travel through a thin ring of dust because tiny grains from comets and asteroids drift inward toward the sun. As they slowly spiral in, some of those grains collect near Mercury's orbit, likely helped a bit by Mercury's gentle pull. Tiny space rock hits on Mercury can also knock fresh dust off its surface and into space. Adding to the ring, meanwhile, sunlight and the solar wind push dust away, trying to clear it out. The exact balance of dust added versus dust blown away isn't fully understood yet. Number 92, the solar system is tilted. The plane in which the planets orbit, called the ecliptic, is tilted about 60 degrees compared to the sun's orbit through the Milky Way. This means our solar system isn't perfectly aligned with the galaxy around it. It's slightly askew, like a spinning plate on a tilted table. Astronomers think this tilt could have come from a collision or the gravitational pull of nearby stars billions of years ago. Number 93, Uranus's atmosphere was studied via stellar occultation. Astronomers learned about Uranus's atmosphere by watching it pass in front of a distant star. As the star's light went behind Uranus, it had to shine through the planet's thin gases, so the light got dimmed and bent in a very specific way. By measuring how the star's brightness faded and recovered, and how different colors were affected, they could map temperature, pressure, and hazy layers in Uranus's air. The same trick works for the rings. When a ring crosses the star, the light drops in quick, sharp steps, revealing a ring's location, thickness, and particle size. Number 94, the sun takes 8 minutes to reach Earth. Light moves incredibly fast, about 300,000 kilometers per second, but space is so vast that even at that speed, it takes time for sunlight to reach us. The distance between Earth and the sun is about 150 million kilometers, and when you divide that distance by the speed of light, you get roughly 8 minutes and 20 seconds. That's why the sunlight warming your skin right now actually left the sun 8 minutes ago. This delay happens because nothing, not even light, can travel instantly across space. So when we see the sun, or any distant star, we're really seeing how it looked in the past, a tiny time machine effect built into the universe itself. Number 95, there's a river of water inside Enceladus. Enceladus, one of Saturn's small moons, hides a global ocean beneath its icy surface, and it exists because of gravitational heating. As Enceladus orbits Saturn, The planet's powerful gravity constantly stretches and squeezes the moon. This motion creates friction and heat inside Enceladus, preventing the water beneath its frozen crust from turning into ice. Cracks near the moon's south pole release this heated water into space as massive geysers, forming bright plumes of ice and vapor. Number 96, 128 new moons of Saturn found. How? Today's surveys can spot tiny faint objects that older telescopes missed. Using long exposures and shift and stack techniques, they track specks only a kilometer or so wide, moving with Saturn over many nights to confirm they're truly bound to the planet. Saturn's huge gravity and busy neighborhood, full of leftover debris and fragments from past collisions, make it especially good at capturing and keeping little moons on odd, lopsided paths. Add lots of patient imaging, better detectors, and powerful telescopes, and suddenly dozens of previously invisible mini-moons pop into view, pushing Saturn's moon count to around 274, the most of any planet. Number 97, airless worlds preserve ancient history. Why? Because nothing is around to erase it. Without an atmosphere, there's no rain, wind, or ice to weather rocks. Without liquid water and thick air, there's little erosion, and many small bodies also lack plate tectonics that would recycle the surface. So when meteoroids slam into the moon, Mercury or asteroids, the craters and impact scars just stay, sometimes for billions of years. By contrast, Earth's air, oceans, volcanoes, and moving plates constantly renew its crust, erasing most ancient marks. Number 98. The edge of the solar system isn't where you think. The solar system doesn't end at Pluto because the sun's gravity and solar wind reach much farther into space. Even beyond Neptune and Pluto lies a vast region filled with icy objects, the Kuiper Belt, and far beyond that, the distant Oort cloud, where trillions of frozen bodies drift slowly through space. The sun's gravity still holds these objects in orbit, which means they're technically part of our solar system. This invisible boundary, where the sun's influence finally ends, could be about 1,000,000 astronomical units, nearly 15 trillion kilometers away, almost halfway to the next star. Number 99, one day all the planets will drift away. In the far future, when the sun becomes a white dwarf and loses much of its mass, its gravity will weaken. Slowly, the planets will spiral outwards, some escaping completely into interstellar space. Our once orderly solar system will scatter, leaving the sun alone, surrounded by frozen remnants of its former family, a quiet, haunting end billions of years from now. Number 100, we're made of stardust. Every atom in your body, carbon, oxygen, calcium, iron, was forged in the heart of a star that lived and died long before the sun was born. When those ancient stars exploded, they scattered their elements across the galaxy, eventually forming new stars. Planets and life. So when you look up at the night sky, remember, you're not just in the universe, you're made of it. And that's our 100th fact. If you enjoyed this journey through the solar system's hidden wonders, don't forget to like, comment, share, and subscribe for more amazing space stories, because the more we learn about the universe, the more extraordinary it becomes.